understand how hydrophobic, hydrophilic, and amphipathic molecules interact with one another, and I will teach you using an example of an everyday situation. Let's talk about how soap works. Let's say you put your sweaty clothes in the wash after a trip to the gym. You've already walked all the way upstairs by the time you realize you forgot to add soap. It's more effort than it's worth to go back downstairs to add the soap, so it should clean just fine in the warm water, right? Wrong. Let me tell you a little something about how soap works and how lack of it has no effect on dirt and grime. Let's break down what happens to your sweaty shirt in the washing machine full of water without soap. The oil from your skin is largely comprised of triglycerides, which look something like this. This is the long hydrocarbon chain of the 3 fatty acids. This makes triglycerides mostly nonpolar. The water in the washing machine is comprised of 2 hydrogen molecules bound to an oxygen molecule. Notice these partial charges. This makes water a polar molecule. According to the popular chemistry saying like dissolves like, your sweat spots would not dissolve in the water because the oil from your skin is nonpolar, while the water it sits in is polar. Your sweat from last month is going with you to the gym.
Let's break down what happens to those sweaty clothes when you remember to add soap to the wash cycle. Soap is a fatty acid salt created when a triglyceride undergoes a saponification reaction. We're not going to go into that, but here's what it looks like. Notice the long hydrocarbon chains of the fatty acids. This region is nonpolar and therefore oil-soluble. The oxygen on the end has a negative charge, making this portion of the molecule polar and therefore water-soluble. The oil-soluble region is known as hydrophobic or water-hating, and the water-soluble region is known as hydrophilic or water-loving. This molecule is called amphipathic because it contains a hydrophobic region and a hydrophilic region. To simplify things for the next portion of this explanation, I'm going to draw the soap molecule like this. This is the hydrophilic head, and this is the hydrophobic tail of the fatty acid. So when you add soap, this amphipathic molecule, to the wash containing your sweaty clothes, here's what happens. The soap molecules form what is called a micelle in the water, arranging their nonpolar tails together in the center of the sphere they create. The polar heads, which are hydrophilic, are the only portion of the molecule that has contact with the water in the washing machine, allowing it to move through the water. Remember, the sweat stain is a fatty acid, which is nonpolar. I'm going to draw it like this for simplicity. When the soap has reached the sweat stain, it rearranges so that the nonpolar tails attract the nonpolar oil. Again, allow this micelle to move through the water, but this time it is carrying the oil. The oil is carried away as the water drains from the washing machine. And voila, the sweat stain is gone. Maybe next time that cute girl on the elliptical will say yes when you ask her for her number.